Alright guys, I have a piecewise question today. Now let's take a look. We have a function defined as f of x equals, now there's three things going here. 7 if x is less than equal to 3. -7 if x is greater than equal to 4. And then in the middle there's this kind of weird thing. It says ax plus b if x is less than, oh, I wrote that wrong, sorry about that. If x is greater than -3, oh, -3 right over there, x4, like that. Alright, so we have this piecewise function. Now, it's kind of like missing this middle piece, and that's where the question is. The question says, find a and b such that f is continuous. Okay, now we don't need our specific, limit definition of continuity here. We just need the general idea of what it means to be continuous. And what it means to be continuous is that you have a smooth curve or a smooth line with no gaps or jumps or holes and stuff like that. Now, we want to figure out, well, first of all, what does this look like, just generally speaking? Generally speaking, let's just draw a graph. Okay, we can't really graph this middle part yet, but let's graph the other two parts. Now again, you have to understand what a piecewise function means. It says, over this domain, here's the function. Over this domain, here's the function. So let's start down here at -7. It says if x is greater than or equal to 4, the function is the constant function -7. So let's mark off here 1, 2, 3, 4. So for everything to the right of x equal 4, the function value is going to be -7. So -1, 2, 3, 4, 5, 6, 7. So there is y equal -7. So if I was just going to graph the function y equal -7, it would be a horizontal line at -7. But I don't want to graph y equal -7 over the entire real number line. I want to graph it just over the x values, x greater than or equal to 4. So I draw this right here. Okay, it's going off to the right. Now it is f of x does equal -7 if x is equal to 4. So I put a closed dot there. Okay, now let's look at the other side, the top of this piecewise function. It says if x is less than or equal to -3, return the function, the constant function, 7. So that says for any x value less than or equal to -3, we're going to draw the constant function 7, which is, we all should know at this point, is a horizontal line with a y-intercept of +7. So 1, 2, 3, 4, 5, 6, 7. So if I was going to draw f of x equals 7 over the entire real number line, it would be just a regular old horizontal line. But I don't want it over the entire real number line. I want it only for x values that are less than or equal to -3. So I only draw it like so. Okay. Now, again, just like before, at -3, at x equal -3, the function value is 7. So there is a closed dot there. Okay. Now the question is, what needs to happen here in the middle such that the entire function f is continuous? Okay. Now this specifies right here that we need to find a linear function. There's lots of functions that would work. we just need to figure out a way to connect this with some sort of smooth object. Now this is saying a smooth line. It could be a smooth curve if you wanted to be fancy, but the easiest way, and what we're supposed to do here, is find a linear function. Now, what are the coordinates of these 2 points? This is the key here. What's the coordinate of that point? Well, the coordinate of that point is 4, -7. What are the coordinates of that point? They are -3, 7. So I think we should all be very good with how to find the equation of the line that passes through those 2 points. Now, what we need to do here is find slope. That's step 1. Step 2, use point slope form. Step 3, convert to y equals mx plus b form, because that is the slope-intercept form that is required for this particular problem. Okay? Now, let's label those points. It doesn't really matter which one. You always label your points, because if not, you'll get confused when you're doing your slope formula. So let's just label. Let's say x1 and y1, x2 and y2. So m equals y2, so -7, minus y1, which is 7, over x2, which is 4, minus x1, which is -3. So we get -14. Be careful of those negative signs. -14 over, that's +7, equals -2. All right, so what we want to do here is find the slope, use point slope form to find the equation of the line, and then convert that equation to y equals mx plus b form. All right, so we have found the slope is -2. All right, now what is this right here? This is something you need to have memorized. It's y minus y1 equals m times x minus x1. Now, conveniently, we already have a point labeled x1 and y1. Let's just use that. Technically, we can use either of these 2 points, but since I already have one labeled, let's use that point. Here's our slope. All we have to do is substitute. So we can say y minus y1, which is 7, equals m, which is -2, times x minus x1, which is -3. So y equals -2x. Oh, let's see, that's -6 plus 7. Y equals -2x plus 1. Okay? So I contend that this is the linear equation that should connect those 2 dots. Okay? We can verify. Let's see here. What is this equation at 4? It should be -7. At 4, y equals -2 times 4 plus 1 equals -7. So on this line is the point 4, -7, which is exactly what we wanted to happen. What about at -3? At -3, y equals -2 times -3 plus 1 equals +7, which tells us the point -3, 7 is on that line. So we have successfully found a linear equation that connects these 2 horizontal lines. And so, let's see, last thing I suppose to do would be to identify the A and the B. So A equals -2 and B equals 1. And there you go. This function is now continuous. It's not a curve, it's lines here, it's linear over these specific domains, but there's no holes, there's no gaps. There was a gap here in the middle, but we bridged the gap, and now there's no holes, no jumps, no gaps, and we are good to go. If you need more help, just let me know.